Hello everyone, welcome back. I don't know which part we are already for this video, but yeah, it's quite an extensive project, the restoration of this tube radio. Last video we did the power supply and the output stage, and we already managed to get some sound out of it, which was a nice surprise that it was working so well. And in the meantime, I've been quite busy. I have drawn the schematic a bit further. So see, I also added the two next tubes. So this is the preamp and the detector, and this is the IF amplifier. Then we have the mixer oscillator and the RF amplifier are still not on here. That's still to do. But as you see, I managed to go quite a bit further in reverse engineering the schematic. And the schematic that I had from John Coster, it was quite okay. There were a couple of differences. See, this was the schematic that I was using as a reference, notably here around the detector tube, the way that the cathode was coupled back to the top connection to the grid. That was completely differently drawn here, and also the biasing with the cathode resistor and the bypass resistor was quite different. For the rest, there are not lots of differences here. Those are the biggest ones that I found. Anyway, we're gonna focus on the detector first and the preamp. And I've also been quite busy here on the radio itself. Let me show you. Oh, it's getting heavy. Okay, so I have replaced here the capacitors around the detector. So that means these four, so this one on the cathode, this one, that one on the plate, and here that one on the, what is it, screen? Yeah. So those four have been replaced, and that's these guys that you see over here, these two in the back, this one and that one in the back. Let me bring you a bit closer. So you might be wondering why am I not restuffing things like this can and the filter cans, and why am I just putting here these capacitors next to them instead of restuffing the original? Well, I figured because it doesn't make much sense. I mean, it's not gonna look original anyway. All these caps, they don't really look original, and for some values they are so low. For example, this is 220 picofarad, this is 500 picofarad. I didn't even have yellow caps that are rated at 500 volts or more, and yeah, in these low values, so I had to swap them out with these type of caps which look totally modern. So it's never gonna look modern anyway. So I figured, why go through all the effort to remove this can and restuff it with new capacitors so that it looks original, when at the same time all these ones are not going to look original. So yeah, that's why I decided to do that. Now, related to the caps that came out, there is something interesting to say as well. Let me show you. I'm just gonna grab my multimeter here. Capacitance, sorry. And these are the two caps that came out, the two 100 nanofarads. One is from the screen, the other is from the cathode. And look at what they measure. 110 nanofarads. So that's what is still perfectly in spec after 90 years. Can you imagine? I was really surprised when I measured these capacitors. Now, obviously, I haven't measured if they're leaky. They could very well be leaky. I suspect they are, but still, the fact that their capacitance is still in the ballpark of what it should be, I think it's quite remarkable. See this one as well, 107 nanofarads. I mean, that's ridiculous. It really is. And for these two, these are very much smaller values. There, I'm gonna take my cheap Chinese tester. And this one is 500 centimeters, so that's about 550 picofarad. I replaced that one with a 560 picofarad capacitor. That one reads 637. Okay, that one is slightly high, like 20% high, but it's still incredible. I think that it reads in the same ballpark. This one is 200 centimeters, so that's 220 picofarad. Let's see what we get here. Yeah, 350. Okay, that one is definitely high, 50% high. But I'm now, I mean, a bit, yeah. I should have tested the radio without swapping the capacitors, because I think it might still have worked, maybe not perfectly, but it might still have worked, which is, yeah, I think impressive for 90-year-old caps. Even the ones around the output pentode were still in a correct ballpark, so that's impressive. This one was definitely not. I can show you. That one was the hum cancelling capacitor that we talked about in the last video, that gets a huge amount of AC voltage across it. And I think it's this side. Yeah, this is 100 nanofarad, or should be, and it's measuring 330 nanofarad. So that one is clearly done. This one, that's the cathode bypass cap of the output tube. That should be 500 nanofarad, and that's measuring 2 nanofarad. What? That one is completely done. So yeah, indeed, 2 nano. These are done, but the other ones, they seem to be quite okay. Okay, but let's have a look at the detector stage first. So here we have the 2B7. That's this guy. I labeled it because the marking was gone. Now this tube has two functions. It's doing the preamp, and it's also doing the detection. So you have two diodes inside and a what is it, a pentode? Yeah. See, so it's using a pentode for preamplification and the two diodes for the detector. So what is this? This tube is like, is that a heptode or something? Wait, yes, a heptode. You can also see that because this connector over here, that's the pickup input, the phono, and that is wired here directly. So one piece of the connector is going to ground. The other side is going directly to the grid of the pentode. The grid is here on the top connection of the tube. And then you have, as I said before, the heater is on the first and the last pin. So then the diodes here on pin 4 and pin 6, they are wrongly drawn on my schematic here. Son of a... Yeah. Wait. Yeah, so normally they should be connected together. I see that I missed the link here. Ah no, they are on pin 4 and pin 5. Sorry, I was a bit confused. Pin 6 is the cathode. Okay, so you have pin 6 is the cathode, and the cathode is shared between the pentode and the both diodes. And then you have here the cathode resistor and the cathode bypass capacitor. And then we have here on pin 4 and pin 5 the diodes. They are connected together, see? And then they are simply connected here to the the transformer, IF can. And the other side of that is connected to the grid of the pentode. And then we have the screen here, which is tied to B+. This is the B+ rail through a 580k capacitor and a 580k resistor and a capacitor to ground for the screen. And that's it. And yeah, I think that's it. So it's quite a simple setup. I mean, it looks a bit convoluted because you have all these functions in the same tube here. But once you start drilling down, it's quite simple. Now let's check if this tube is still okay. That's dark. It's a beautiful tube, I must say. It looks fantastic. The construction is really nice. The nice thing about these big tubes is that you can still see the parts inside. You can see the diodes, you can see the pentode. It's really beautiful. Okay, we are back at the tube tester. I've already put in the 2B7, also connected the top connection here, and I've already set everything normally to test the pentode section, which means that on pin 1 we've got the filament, and how many pins has this thing? 6 on the bottom and 1 at the top, I believe. So that means pin 6 is to ground, so you have the filament on pin 1 and pin 6. Pin 2 is the plate, pin 3 is the screen, and pin 4 is, the rest is all chassis or ground, set to ground. And then pin 9 on the tube tester here is also exposed here on this socket, so you can use it to connect the top. So the top is pin 9, selector switch number 9, that is set to the grid. So the top here is the grid. We've got filament voltage set to 2.5 volt, grid bias is -3 volt, the plate is 100 volt, and the screen is 100 volt, and the plate is 250. And let's see what should we get actually? 6. We should get 6 milliamp. Okay, so let's hit measure and then set the scale of the dial to 10 milliamp and then see if we see something. Yeah, it's coming up. It's coming up really well. 5.5, 5.8, 5.9, 6. 6.1, so it's even going higher than what we have in the specification, in the manual of the tube tester. 6.2, so that's more than 100%. That's really good. Let's see the mutual conductance. That should be 1 milliamp per volt. So let's see, if I increase it with half a volt, I measure 6.7, and if I decrease it with half a volt, I measure 5.8, so that's 0.9 milliamps per volt. So that's 90%, because we should have measured 1 milliamp per volt, and we're measuring 5.8. Yeah, that's 0.9. So that's really good. So the pentode is really good. That's great. Now let's test the diode sections. There are 2 diodes inside here as well. Let me just set the tube tester here. Okay, so to test the first diode, we have the filament stays the same. All the other switches are set to ground except pin 4, which is the first diode, which it's connected to a 100k resistor. Screen is set to 0 because that's not connected in this case, and the plate to 100 volt. And then we should measure 1 milliamp. Okay, let's see what we get, and let's change the scale to 3. We should be over here somewhere when it starts conducting. Yeah. Yes, perfectly spot on 1 milliamp. Okay, that's good. Now the second diode, then it's simply setting this pin to ground and connecting this pin to the 100k resistor. And let's test again. 1 milliamp. Yeah, 1 milliamp spot on. So wow, this tube is perfect. It's almost like new. So let's put it in the radio. like that, and let's put its cap on top. Okay. Yeah, I think we can power up and see if we get something. Because now the volume control will be doing something. So I'm just gonna put it somewhere in the middle and see what we get. It helps if you plug in the power of your dim bulb limiter. Okay, we have 219 volts going in, 220. Don't hear anything yet. Oh! Yeah, I hear some crackling in the speaker. Haha! Whoa! Woo! Oh, wow, there is quite a bit of oscillation here. Whoa! Aha! That's better. Now, this switch, let me turn this off here for a second. If you were wondering what this switch is, I didn't expand on that one in the previous video, but let me show you. See, that's this guy over there, and it's wired quite peculiarly because it's basically blocking or opening the feedback, negative feedback on the output tube. So see, you have the plate here, which is connected to the grid via a 200 centimeter or picofarad capacitor, and this switch to the grid. So this is a negative feedback loop, and so you have a means of opening this up. I don't know why you should do that. See, if you now the switch is closed, so you do have the negative feedback surrounding the amplifier, the output tube. So, and then if you touch the preamp, it buzzes nicely. But if you open up this feedback loop, see, you completely drive the output tube into oscillation. Okay, so let me hook up the signal generator, and then we can see if, yeah, how it sounds now with the preamp in series in the circuit. So I have the signal generator connected to the pickup input, and I have 100 millivolt RMS to start with, and yeah, I've got a nice signal. The volume control is working very well. It's a bit crackly, but I don't think I will be able to avoid that. If you remember how bad the state of the potentiometer was on the inside, towards the end, see, it's a bit crackly. But yeah, that won't be an issue because I won't drive it all the way to the end anyway. Yeah, it's working rather well. Okay. Now, next step is to check if the detector is working, but I expect that it will be. Okay, I've got my signal generator here hooked up between ground and the plate of the next tube, so the IF amplifier, which is not in place. So that's where normally the signal would come in. So let me show you here on the schematic. So this is the tube that we haven't talked about yet. That's the next one. That one is not in place. It's the IF amplifier. So I have the signal here connected on this pin. Then it should go here to this transformer and then be decoded and amplified. Let me show you what I have here on the signal generator. I have a 155 kilohertz signal with a tone modulated on top of that one. And I took 145 kilohertz because that was actually what is mentioned here on the schematic of John Koster, which I found online. See, IF frequency 145 kilohertz. Now, let me see, let me show you what happens. So if I enable the modulation, see, you can hear it. But the volume is all the way up. And I'm at 1 volt RMS. And it's very, let me put the microphone a bit closer. I don't know if you can hear it, but it's very faint. So let me change the frequency, the IF frequency here, and see if we are at some, if this can is tuned for something else than 145. Okay, let's go up. Let's go to 155. No, now it's even more silent. Let's go to 135. Yeah, it's getting louder. 125. Very much louder. 115. Yeah, no, it's, I think, a bit more silent again. Let's go back to 125, yes. Okay. 120. Yeah, it should be, I think it's tuned for around 120, 125, something like that. I can figure it out better when doing a sweep and watching it on the scope, but the detector is working. That's great. Now, the thing is that I don't know what this should be set for. So, for example, we can take 125. I don't know what the IF frequency for this radio should be, because there is no documentation whatsoever available. We can take something. Yeah. Anyway, the detector is working and the preamp is working, so we're doing quite well here, I think. Just for reference, I put my multimeter on the volume control, and the maximum is at 121 kilohertz. So this can is tuned for 121. Okay, next step is the IF amplifier. So let's have a look at our schematic again. And it's blown out again as usual. This is the 58 tube, and it's a simple pentode, and it's an IF amplifier. And that one is located over here. So this is the IF amplifier, that's the mixer oscillator, and that's the RF amplifier. So these are the 3 tubes that we still need to do. I've already replaced the capacitors that are concerning this tube, and that's this guy over here. Actually, I should have already replaced it, I think, because it is this one. Don't mind the thing that I drew here, just I'll talk about that later. It's this guy over here, which is connected to via a 1.35 meg resistor to the phono stage over here, but it's also connected to the IF can of the previous stage. So it's a bit of a feedback as well. Now again, this resistor, yeah, one thing about the resistors, because I haven't mentioned that yet, all the resistors in here are covered with heat shrinking, and it's stuck to it. I can't remove the heat shrink. So that's quite annoying, because there is no way to know what the original values here of these resistors would have been. I only have the measurements from the schematic of John Koster. They match more or less what is on that schematic, so I'm gonna leave all of them. But yeah, I don't know why they covered all the resistors with shrink-through tubing or with sleeving, but it's really annoying because I don't know any of the values of any of the resistors. But yeah, that's life, I guess. So this is that 1.35 meg resistor, goes to the IF can on this side and then via this capacitor to ground. So that is this one replaced. Now the next one that I replaced is this guy all the way over here on the left, whereas the tube is there on the right. And that's here, this capacitor connected to the cathode and the screen. Now, why is this one all the way here on the left? Well, now we're getting into the differences which we have on this radio compared to this schematic. Because this schematic has one tube less, it doesn't have an RF stage. See, we have here only a 58 as an IF amplifier, then a 2A7 as a mixer oscillator, and then there is no tube in the RF stage, so there is no RF amplifier. We have one, this guy over here, and that's the same type of tube. So that's also a 58, this one, just like the IF amplifier. It's a tube that can be used as an RF or as an IF amplifier. And what they are doing is they are using this capacitor as the, they share it between both tubes. See, so here we have, I haven't drawn the RF stage yet, but here we have pin 4 and pin 5, they are connected together, and they are connected through this 100 nanofarad capacitor to ground. And basically, pin 4 and pin 5 of this tube are connected together with pin 4 and pin 5 here of this tube, and then here you have the capacitor to ground. So that one is used for both tubes. Now what is also interesting is this wire over here that's going all the way up to that potentiometer. Let me put you even a bit higher. See, that's this wire that I drew over here on the schematic. And again, we have here a resistive wire. So that acts like a 200 ohm resistor. It goes here from this pin 4 and pin 5 of both tubes. It goes to the potentiometer here on the top. See, that's what I drew here. And the wiper of this whoa, I'm out of shot, sorry. See, that's what I drew here. 4 and 5 are connected together through a 200 ohm resistor to that potentiometer and a wiper to ground. Now, what this is simply doing is with this potentiometer you can open up or close this tube. And since both tubes are connected together, with this potentiometer you can open up or close both tubes at the same time. So this is a sort of manual gain control. It's a quite primitive way of changing the volume. So this radio doesn't have automatic gain control. So that means that if you have a very strong station or a very weak station, they will come in at a different volume. So with this guy over here, this potentiometer, you manually need to tune the gain. So if you change to a station which is louder, you need to decrease the gain here with this potentiometer. Now, this model over here, the one that I found online, that's the only type of volume control that it has. See, this is also marked here on the schematic with volume. It doesn't have a volume control in the amplifier. So that was a more basic version of this radio. This potentiometer, which is our real volume control, let's call it, was not present on this one. So the only way that you could change the volume was with this guy and by changing the gain on your IF stage, because it didn't have an RF stage, so only the IF stage. So that's a really primitive way of changing the volume. Here on this radio you have both, so you can fine-tune the gain, but you can also change the volume, the real volume in the amplifier. So from now on I shall call this one the volume control and this one the gain control. So that will be interesting to actually use this mechanism. Let's get the 58 tube that we have here in the IF stage. And that is this guy. There is not much to see because it's coated fully in a shield. So let's put it in the tube tester and let's also see if it is still good. Okay, here we are again at the tube tester. the 58 tube is in the correct socket, and I already put all the switches in the correct place. So this has 6 pins on the bottom and 1 on top. So 1 and 6 are again filament. 2 is the plate, I think. Yes. Pin 3 is the screen. Pin 4 and pin 5 are connected to ground. We have the filament to 2.5 volts, the grid bias or the grid voltage -3. The screen is 100 volts, the plate is 250 volts. And let's fire up the tube tester. Okay. And let's see what we measure. What should we get here? It's a simple pentode, so it's one test that we need to do. 8.2 milliamp is what we should measure here. Oh yeah, and pin 9, which is this one, is the grid, obviously, on top. I'm putting the scale to 10, so we should measure 8.2. Do we see something happening? Ah yeah, there it's coming up. 1, 2, I have a feeling that this is not going to reach 8. 3, 4, 4.5, 5, come on. 5.5, it's still climbing, but really slowly. 5.7, 5.8, but that's nowhere near the 9 that we should have measured, or the 8.2 that we should have measured. Yeah, 8.2. Let me get my calculator. Meantime, it's still climbing very slowly here. Yeah, it's almost at 5.9. Let's give it 5.9. 5.9 divided by 8.2. That's 72%. That's, yeah, like we would say in Dutch, met de hakken over de sloot. So that's only just good enough. Let's see what we get in terms of mutual conductance, because that's maybe more important. That we should have 1.6 milliamp per volt. So let's see. We are at 6.3 minus 5.5. That's only 0.8. That's only at, and we should have 1.6, and we have 0.8. So that's really bad. That's only 50% of what it should be. That's really bad. Let's check again if I was measuring correctly. 6.4 minus 5.5. So that's 0.9. That's 56%. So that tube is bad. Or, well, not bad, it's weak. Very weak. Interesting. It will still work, I guess, but I need to pick up a new one to replace this one, I think, because that is a weak tube. Now, while we are testing this one, let's also test the RF amplifier, because that's also a 58 tube. Let's see where it is. Put it in here. And I still have the settings set on the tube tester, so we can test it easily. Again, we should have 8.2 milliamps. Let's see what we get. Takes a while to warm up these tubes. Oh, my scale. Setting the scale to 10. Okay. That one is coming up much faster. See, we are already at 6 milliamps. 6.5. 7. Okay, and it's still climbing. 7.1, 7.2, 7.2. And still climbing slowly. 7.3, let's give it 7.3. That's 89%. That one is much more powerful. Let's check the mutual conductance. We should have 1.6 there. It's already at almost 7.4. But let's check the mutual conductance. Oh, that one is much stronger. 8.2 minus 6.8. I think. Yes. 8.2 minus 6.8. That's 1.4. And we should have 1.6. So that is 87%. So that one is really strong still. That's a good tube. Now, which one of the two should I use now in the IF? I don't know. Anyway, I'm gonna pick up one new one for this, I think. Having a good one in the RF, I think, is also quite important. But, yeah. Okay, we have one weak 58 and one very strong 58 tube. Okay, so I've got here the 58. That's the weak one that I got here. Simply because that one was originally here in this position, so I'm gonna put it back in its original position, and then when I have a replacement I will change it out. If it doesn't work, I will use the RF, the one from the RS stage temporarily. Okay, let's turn on the radio again. I have it turned on here, right? Yes. With this new tube in, I have my signal generator hooked up to the grid of the 58. I don't have a signal in there yet. Let's just first let the radio read up. If you hear some noise, there's a storm outside, so that's probably what you're hearing. Okay, so we have... it's alive. Let's turn on the output here. Modulation. Whoa, okay, it's coming through quite well. This volume control, there is still something wrong with it, I think. I might need to change it after all. This is the volume control, but hey, the tube is working. See, the volume control is... I think I need to change it. But okay, let's put it over here somewhere. I have, for your info, 100 millivolt RMS, 121 kilohertz, and because that was the peak of this IF can, and 1 kilohertz tone modulation. And now with this potentiometer, we should be able to open up and close this tube. Yep, that's working. So this is the gain of the IF stage that we are now controlling. Let's put it all the way open. And then this is the volume of the amplifier. It's quite cool, huh? But so far everything seems to be fine. Yeah, great. Not really a spectacular video, but hey, we've made again a bit of progress. Now the thing is, if I want to go a stage further, then I have to continue drawing my schematic here. And that's not easy, because it's getting quite convoluted and quite complicated with all the tuning cans here. It's not easy to reverse engineer the coils which are in the cans. So I'm gonna think a bit about how I'm gonna tackle that. And then, let me turn off this beep. Sorry for that. I'm gonna think a bit how to tackle that, and then we can finish off the rest here, because we only have 2 tubes to go, and yeah, then obviously aligning everything. So let me think a bit about that. Okay, so I decided to go ahead and remove the remaining, replace the remaining capacitors. So that's true. There were 3 left. This one, and this one. This one was quite interesting because it was located all the way to the side here, and its leads were extended to reach those 2 solder points over here. So I guess there's maybe a reason for that they wanted to keep the capacitor away here as far as possible. This is the first tube, so you see the antenna connection is coming in over here. So this is the first, no, not the first tube, the first coil. So maybe there's a reason why they put that so far away. So I also extended the leads here to get it, to put it there. And then, yeah, these 2, they are around the mixer oscillator. So these were also replaced. I haven't drawn the schematic yet of everything here in the RF section and in the mixer oscillator section, but I just decided to go ahead and see what we get, replace the capacitors and see what comes out. Yeah, this one here was also replaced. There's only 1 tube left that we haven't talked about yet, and that's this guy. This is the 2A7, and that's the mixer oscillator. Also, yeah, you can't really see anything because it's shielded. Now this is quite an interesting tube because it's an heptode. So it has the cathode, the anode. So heptode means 7, right? So cathode, anode, and then 5 grids, which is quite significant, and it's used for all the mixing. Some of them are used for the oscillator, and then they are fed back in via another grid and then mixed in with some others, with the RF signal and all this shenanigans. They are also only handled by this 1 tube. So unlike in more modern radios where you have the mixer oscillator, which has 2 separate sections, you have like a triode and a pentode or something, like the ECH81. The C is the triode and the H is, I think, a pentode. Anyway, this one just has 1 heptode with 5 grids, and then it uses the same internal layout to do both the mixing and the oscillating. Now I tested it already. I'm not gonna bore you again with putting it on the tube tester. And interestingly enough, the gain was really good. Came out at 106%, but the mutual conductions was really low, only 53%. Which is something that you see quite often in tubes that need to do oscillations, that the part that has to do the oscillation is weak. So yeah, I'd say let's plug it in. It still works, but it's weak also. Well, at least the mutual conductance is weak. Let's plug it in and see if it works. I mean, yeah, it won't blow up since I tested it already on the tube tester. Okay, so I swapped things around a bit here because now the speaker is more directed towards the microphone. So if something comes out of the speaker, you should hear it a bit better. Let's put the 2A7 here in. Where are the key pins? Over there. And they should be like this. This is a bit awkward because it's a difficult position to plug it in. Well, it's especially more difficult to take it out again. But okay, let's put the cap on top. Right, now the 58. Here we have the 58. See. Okay. And let's also put the cap on top. Now I don't have an antenna connected. Maybe I should connect something. Maybe just a wire or something. Let's first start it up like this and see what we get out of it. This is the on-off switch, right? So this is the on-off switch and also the gain of the 58 tubes, so the RF and the IF amplifier. This is the volume control, and this is the bandwidth selector, so medium wave or long wave. I haven't checked that yet, so I don't know what will happen or what it will do. Yeah. Okay, I just turned on the power. We're getting 190 volts going in, 200 volts. $200, 190 now. It's dropping again, 180. So the voltage is a bit low. Okay, do I hear something? No. The amp is working. But I don't hear anything. Nope. Nothing is happening, but I'm only at 178 volt. Maybe I should, let me just add the B plus here, just a sec. Now the interesting bit is that I can simply take the B plus via one of the connections here in the back. This is chassis, and then the B plus is over here somewhere. I think this one. Yeah, 201. So I think we can safely go a bit higher here. How many watts do I have here now? 40 plus 25. And it's 65 plus, that's 80 watts that I got here now. Let's go to maybe 100 watts. We're at 196 volt now going in. Let's go to 125 watts. Now we are at 212 volts going in. 260 volts on the B+, that should be okay. Something is happening here, but maybe I should attach an antenna to see if it is actually doing something. Let me just plug in a wire here to see if that makes a difference. These are the antenna connections. I think this is the antenna connection. No. It's not doing anything. Oh, wait. Is it trying to pick something up? Yes. Ha! But it's really weak because I have to put the gain all the way to the max. Oh my god! I can't believe this. I don't know if I'm on long wave or medium wave. And it's just with the, I just have a test lead here now connected as an antenna. Wow, that was not the goal. But wow. So that's a very bad antenna, obviously. Very weak signal, so maybe it's normal that I have to put the gain all the way up.
Speeches which are delivered as if someone is being stabbed.
I don't know if this is long wave or medium wave. Let me switch the band here.
Oh, absolutely. That is certainly going that way. He was 8 to 1.
That one is also working. Incredible. Incredible. And yeah, my antenna is here. I don't even have, just have the test lead as an antenna here. I just now put the test lead onto a metal plate that I have sitting here. So I'm now using that as an antenna. And it's working really well. I think this has to be medium wave. And because it doesn't have automatic gain control, you between the stations you hear silence, because the reason why you hear noise or hiss or static in between the stations is because if a radio has automatic gain control, it completely maximizes the gain and then you hear the noise. But if you have a radio without automatic gain control, if you then tune out of a station, you just hear silence. Maybe I should hook up the mini whip. Give me a minute. Okay, so this is with a mini whip. Listen to this. Yeah, this is clearly the medium wave.
8:30, 7:30 en Canarias.
Expósito y Carlos Saez.
Deportes en la linterna.
COPE. Estar informado.
Deportes en la linterna. Charlie Saez, todo tuyo.
¿Qué tal, Ángel? Buenas tardes. Estamos cerrando esta primera ronda de la Copa del Rey en un día en el que hay que hablar del futuro del Real Madrid. Rodrigo ha renovado.
I cannot believe how well this receives. The radio is not even, I mean, I haven't aligned it or anything, right? I mean, I just replaced the capacitors and I would expect that it would be completely out of alignment after so many years and with different components, but man, I don't even know if I have to bother going through an alignment, because this seems like Spain and it's coming in crystal clear, and there is a storm going on outside, so, and I'm only at 211 volts, so I can even add a bit more to get it to 20 volts.
Los compañeros de relevo y que ha podido confirmar Deportes Cope, Adrián López, el portero del Granada, inscrito en el filial, 24 años, con una circular que haría que el Granada... Pronto que tarde deje de ser precisamente por eso pasamos este engaño masivo del que todo país.
Este orgol spațial, deci plimbare organistică, începe și la noi, cum sunt străzile deschise, orcile deschise. E interesant fiindcă sunt poate locuri unde se ajunge mai greu și în mod deosebit.
No, I do notice that I have to turn on the gain control almost completely to the maximum, and that's probably because all these stations here, they are quite far away, so they are pretty weak. We don't have any local stations on AM anymore here in Belgium, so yeah, this probably was to differentiate the gain between very strong local stations or very far away and weak stations, but from our perspective today, they are all far away and weak, so...
Construite de același constructor sau care aparține aceleași școli de construcție.
Y lo que el reglamento del Senado, por la misma... Estamos que se pueda... Para que la cámara...
Okay, let's try the long wave. There is not much on long wave anymore these days.
So it's not entirely a sort of Kleenex
This is BBC.
Collection of poems. But yes, I wanted that element. We wanted that element of surprise there. We wanted this sense of poem speaking.
So my goal with this radio was actually to be able to use it to receive BBC from Droidwich before they shut down in March or April next year. Well, I wasn't expecting that I was going to immediately receive it already on the first try.
But that's a poem which uses, in a very sort of knowledgeable but moving way, all kinds of things from its past, and whether contemporary poets know it or not, and of course a large number of them.
Let's see if we can also get Algeria.
There is that broad movement, though, isn't there, from the elegies?
Yep, there it is, I think. Very weak today. Yeah, that's Radio Algeria. Amazing, awesome. Ha. I am really happy with this. Now, okay, how do we move along from here? Fantastic, really good.
Pues la idea de país en país y de ciudad en ciudad, ¿no?
So the tone control switch does actually make a difference. Listen to this. I mean, I think I was wrong, or I'm missing something here, or I'm just too stupid to understand how it works, but it does work.
Korába kezdett magyarul tanulni, ez egy német származású, talán Herzog volt az édesapjának is, meg neki is a neve.
És ő maga se tudott így van magyarul.
Én úgy tudom, hogy ezért, mert került Szegedre középiskolába, hogy ott aztán a magyar nyelv szépségeit alaposan megismerje.
És meg is ismert.
Meg is ismerte, sőt nagyon jól. Hát Molnár Ferenctől tanult igazából, vagy legalábbis nagy figyelemmel kísért.
Yeah, it actually works. It sounds better in the up position.
Tanult meg darabot írni. 3-szor terjesztették fel Nobel-díjra.
Interesting.
35-ben, 36.
So I think that's quite a nice note to end this video. A bit unexpected, because I was actually only planning to do the detector and the IF stages, but hey, we got the radio playing, so nice surprise. Now, what I'm still wondering is if I should do an alignment or not, because it's playing pretty well, and I don't want to break anything. And I don't have alignment instructions for this radio. I don't think it will be too complicated to do one, but I don't know how these cans will react, how these coils and these capacitors will react. And it's basically playing. So I don't know. I don't know if I need to do an alignment. I also don't know if I still now need to still pick up some tubes which I measured as weak, because it's working. Yeah. Interesting things to think about. If you have any opinions, let me know. And I think, yeah, electronically wise, the only video that might still come is then an alignment video, but then we are done. And well, on the electronics, because I still have a lot of work on the cabinet. Honestly, I haven't even started it yet, so there's still a lot of work on that one. It needs complete revarnish, so the old varnish has to come off completely. We have to apply a new one. There needs to be a new grill cloth. There needs to be a new glass, because there is the glass in front of the dial is gone. There need to be. I need to create a back plate or back cover, because that one is gone. We need a new power cord. I mean, there are lots of things that still need to be done, but none of them in the electronics, I think. So that's good. I mean, I got it working, right? Yeah. Okay. The rest is just manual work on the cabinet. So anyways, if you're still with me with this project and you love what I'm doing, post something in the comments below. Comments are always appreciated. Suggestions are always appreciated. So anyway, I'd like to thank you for watching, and then I hope I'll see you in the next episode. So take care. Bye bye.
Con las pasadas. Sí, Valencia, más que de aquí a poco tiempo, porque las va a tirar
correcto.
Materiales.
4 si te decía.
La semana no juega el Madrid, por lo tanto 3 de los 4 españoles van a tener solo compromiso de Euroliga. Mañana Baskonia y Barça. Laura Magría, se reestrena Ivanovic en el banquillo vasconista.
Así es, Ivanovic iniciará su cuarta etapa como entrenador Partizan en el Buesa Arena y con el objetivo de revertir la mala racha de 5 derrotas consecutivas. Mañana podría debutar el base norteamericano recién llegado Chris Chiota. El Partizan, con un balance de 2 victorias y 3 derrotas, llegará a Vitoria sin Ponitka lesionado. Este será un partido muy embajador, ya que la leyenda de...
Mantle from Mo Salah, Liverpool fans. Is he ready for it? You're listening to Kickoff on TalkSport with Ladbrokes. We play together. Terms and conditions apply. It's 18 plus. BeGambleAware.org. Kickoff on TalkSport with 18 plus.